block capital and take some small time interval and then write these letters clearly. That's something really, really important, right? Okay. So that's all about that thing. And then answer all questions. Usually that's there. And answer the questions in the space provided. So they also say there may be more space than you need. Sometimes while solving the problem, you might encounter the given space is, it seems the given space is kind of like be much greater than required to get to the answer. That's completely fine. So don't worry about that thing. In case you are confident about the method which was followed by you, right, to reach the answer. And one of the very important information again, right? When it comes to the let's say for example working part, right? Usually this is something which is not taken that serious by most of the candidates. Now show all your working in calculations and include units where appropriate. So showing how you have got the answer is something very important. It doesn't mean that. It doesn't mean that, right? Redundant steps are required, like. So it is not required. You are not required, or just you need not to write down redundant steps, right? So just show or just write down the equations and then the correct substitution and then the other important steps, and then finally numerical value of the answer with the appropriate or applicable units, right? Okay. So information, and they're going to say you have that much number of the marks, right? And each question are shown in brackets and blah blah blah. So those things are given here, so you can go through them easily. All right, and now coming back to let's call this paper. So it says read each question carefully before you start to answer it. Something really important, and then you should do. Try to answer every question. So meaning questions are not optional. You have to do all questions and check your answers if you have time at the end. So just get the question done, and then you better move to the next question and keep going that way till the paper is over. And then in case you feel you have enough time, you have some extra time with you, so that you can just implement the time interval to double check your workings, right? Or the places you wanted to, let's say for example, you wanted to double check. Okay. All right, fine. So that's all about that thing, and then we are going to step on to the section A, right? Which is comprised by MCQs, multiple choice questions, and usually in your specifications, you do have about 10 questions, the multiple choice questions, and you will get 10 marks. 1 mark for each MCQ. So usually you have 4 answers, A, B, C, D, and just one. These are single choice answers, meaning only one particular the answer will be correct, right? Or one particular answer will be the most appropriate answer. Now, something you have to keep in your mind is that sometimes answers are not the accurate answers, but you have to go for the most appropriate answer. So therefore, remember, it should be either like the accurate answer or the most appropriate answer, right? Sometimes we can't find exactly especially when it comes to numerical problems. It is sometimes, right? Sometimes I really want to emphasize only sometimes the things like that can be encountered. Sometimes you can find answers, A, B, C, D among these answers, but you won't be able to find out the exact numerical value you got, right, by typing the numbers into your calculator. But there can be an answer in which you have a very close value. probably once that particular answer is rounded off. So therefore, you better just check that particular answer. So therefore, remember, right? The answers are sometimes answers are the not the exact one you are going to get just by using your the calculator. Instead, it is going to be something much closer. So therefore, remember, it should be either accurate or is the most the appropriate answer. Fine, okay. So they have said for questions number 1 to 10, which are going to be MCQs. They say select the one answer from A to D, right? One answer from A to D, and so which means just only the only one answer, right? Only one particular answer will be correct out of A, B, C, D, and the put a cross in the box. If you change your mind, meaning let's say after some time interval, or just after having done another question, you got another point in your mind, and you think particular answer for that question is going to be another one, and not the one you have already marked. In that case, what? Just put that cross that way, right? In this way. Okay. So put that cross, whatever that the stroke, horizontal line segment, which conveys the information that you don't want the examiners to treat that thing as the correct answer. Instead, the new answer you have marked, right? Okay. So therefore, just do that. Stick to that one. That's going to be okay, something you should follow. Sometimes without just sticking to these instructions, sometimes people just cut them down, they shade sometimes, right? So you should not do some stuff like that, right? So just some horizontal line segment across that box. So that's all. Then after that, mark your correct the answer, right? Okay. Now then. Having discussed all this stuff, right? We can take question number 1 into account. Now, in question number 1, they just ask which of the following is a vector quantity? Which of the following is a vector quantity? Right. So it's a very simple question, right? Now, work done. Now, work done, by definition, work done is a scalar quantity. Why? Because if we just take work done as W, so we know W is equal to force multiplied by the displacement along the same direction as that of the force, right? Actually, now in that case, force and displacement, they both are vectors, but the way we are going to define the work is just by using a particular product in mathematics called dot product or the scalar product. So we just write the W is equal to the force F, which is a vector, and dot, and S, displacement along the direction of the force, which is going to give you a scalar output. So scalar product or the dot product, gets that name because the output, the result is going to be a scalar quantity. Now, those who are doing maths, they know. So this is going to be modulus F. So just F, and the modulus S, meaning the magnitude of S, and cos theta. Theta is the angle between force and the displacement in case the displacement and the force are inclined to each other, right? Okay. So therefore, work done is not the answer. Work done is scalar quantity. That's not the answer. Time definitely is not a vector quantity. because they're asking about the vector quantity, something really important, right? So just let's highlight that part. Okay. We want to find out the vector quantity. So fine. And the temperature. Temperature has no direction, obviously, right? So these are obvious answers, obvious the choices. Not the work done, not the time, not the temperature. So only answer which is going to remain is going to be the displacement. That's true. Displacement is the vector quantity. So therefore, so you can put that cross here, this way and that way, and therefore this is going to be the answer in that case, right? Okay. So B is the answer, right? Okay. Fine. Now, if you go for the question number 2, so in question number 2, they just ask something regarding the work done. Now, they say they ask, which of the following is equivalent to 1 kilowatt hour? Now, one of the very important the information, very important fact is that now kilowatt hour, right? So here basically it is watt. So let's say, okay, fine, kilowatt, and then hour means time, right? So now what is here basically, it is just the watt is used to measure the power. We can say just the power multiplied by, here we do have the time. Now power multiplied by time is equal to the, you can say either work done or is energy, right? Basically, okay, fine, let's say that's the energy. So therefore, power multiplied by time, which is measured by kilowatt hours or even watt hours, right? Or some the appropriate units for the power and then for the time as well. So product of these two is going to give you energy. So energy is measured by, what do you say? Either by joules or force into displacement. Newton meters. Now, when you just when you understand kilowatt hours is just power multiplied by time. So therefore, we are going to measure some amount of energy. So you can just omit this answer because it's not correct. What is used to measure the power, but what you are going to find out is some amount of energy. So therefore, it should be measured either by joules or as Newton meters. So therefore, what answers can be omitted or can be dropped? Within a fraction of a second. Now, then after that, we have to answer capital A and answer capital C. They both are given in joules. So now kilowatt hour. So just we can write 1 kilowatt hour. So let's say HR is equal to, now what do you mean by 1 kilowatt? It's going to be 1000 watt, or we can say 1000 joules per second, right? Multiplied by, now 1 hour means 3600 seconds, right? Now in this case, what you're going to get is 3.6 multiplied by 10 to the power 6. So again, we know it is going to be the energy. So it is either by joules or it's by Newton meters. Now you don't have to just keep simplifying. So obviously you can understand it's like 3.6 into 10 to the power 3, and here you have 10 to the power 3. So altogether it's going to be 10 to the power 6. So therefore, that is not the answer again. Answer capital A can be dropped. So we do have the answer here. That's going to be the answer. So you can put that in there. So answer is going to be C. Right? Okay. So the equation we used in this case is something important. Power is equal to, let's say, work done, or you can say energy divided by time taken. So just you can say power P is equal to, let's say, work done or energy E over time. That is what we have used in this case. Okay, right, fine, done. And Okay, then we can get back to the question number 3, which is about the fluid, and it's the motion of a spherical object through a viscous liquid, or the fluid, which includes both gases as well as liquids. Right now, the one important point we have to take into account in this case is that something like this microdynamics usually cannot be done just by thinking, right? This is something you should know. Now, Stokes' law is something which is used to find out talks about the frictional issues, or just we can say friction by fluid, right? So just we can say friction by fluid, right? Now, a frictional force by a fluid is usually called viscous force. Yes, you can write COS or COUS depending on UK English or US English. So I'll say viscous force. Right. Now, this viscous force, if it is F, right? So when an object is going to move through, let's say, a liquid, let's say liquid, and we do have let's say spherical object of radius simple r. Now, this particular force, let's call this drag force or the viscous force, is given by F is equal to 6 times pi eta VR. So that equation, we don't want to remember that equation, right? But that equation gives us some idea about what we are doing right now. I mean, that viscous force or the fluid friction depends on the viscosity. I mean, what's called this coefficient of viscosity of the particular fluid. Let's say, for example, liquid in this case, and V, the velocity of the object, and R, the radius of the spherical body, right? Just like a let's say that the what's called this ball bearing, something like that. And while we were studying about Stokes' law, we have emphasized it, right? Now, there are some conditions to be satisfied in order for us to apply Stokes' law. This number one, this can be applied, I mean, when we have an object which is relatively smaller in size, right? So we can say the spherical object, right? We can say spherical object, relatively smaller spherical object. That's why radius comes into account, and should be a relatively smaller one. So spherical object of relatively smaller in size. So we can say relatively small in size. I mean, the best example we have discussed while we were discussing about the theories was that ball bearing, right? So ball bearing. Okay. And then the another condition, another important condition is that the particular liquid or the fluid should be viscous. It should be a viscous liquid, right? So we can say viscous liquid. At the same time, another important condition, the third one, is that that particular the spherical object, or let's say ball bearing, should move through this liquid or the fluid in a way that liquid is not going to form something called turbulent conditions, right? So, I mean, in order to maintain that liquid in a calm and quiet manner, that particular object, that small object, should move with relatively smaller velocities. So we can say that ball bearing should move relatively slowly, right? Okay, so moving slowly through the liquid. To the, let's say, okay, fine, fluid. Right. Now, there is something important. Now, in case somebody, let's say, you want to know why it is why it should move relatively slowly. The reason is otherwise, right? Otherwise, in case that ball bearing is going to move relatively faster, right? So let's say otherwise liquid will form or will be under something called turbulent conditions. Turbulent conditions. Right? That part is very important. I mean, turbulent conditions. So if it is, let's say that whatever that tiny spherical object which is going to move through this liquid is going to form turbulent conditions. Turbulent means jerky conditions. I mean, liquid molecules are moving here and there. It's kind of like, you know, when you stir the small amount of water, or just, I mean, probably your tea, right? Or just, I mean, when you see how when you look into the ocean, so ripples are moving towards the shore, and when they are going to hit the shore, sometimes the flow is really turbulent. I mean, liquid molecules are moving here and there, crossing their paths and colliding and so forth. So under turbulent conditions, what do you say? The Stokes law cannot be applied, right? I mean, there are versions, so we can make corrections and apply, but not at this stage. Okay, so fine. So I just wanted to, just to recall these factors into your mind. So in order for you to apply Stokes law, right? In order to find out, let's say, for example, the viscous drag or the viscous force exerted by the viscous fluid on the moving object. Now, in order for you to apply this equation, so three main conditions should be satisfied. Number one, the object should be spherical, and it should be a relatively smaller one, and it should be moving through a viscous liquid, or we can say fluid commonly, right? And should move with relatively slow speeds, right? In a way that the movement of the ball bearing or the smaller object is not going to set that liquid in turbulent conditions, or turbulent flow is not caused, right? Any turbulent conditions will not be produced. So therefore, it should be a spherical body, and it should be small. So therefore, large sphere part, right? So large sphere, what do you say? It's not the answer. So capital A is not the answer. And again, we have large sphere. So that's not the answer. Again, here we have small sphere. That's correct. No problem. Here is correct. But moving quickly, meaning it's moving faster. So therefore, that small sphere can set that liquid in turbulent flow, in which case we can't apply Stokes law any further, right? So therefore, quickly mean high speed. So therefore, in that case we can't apply the Stokes law. So therefore, small sphere, that's correct, and moving relatively slowly, that's also fine. So out of these given answers, D is going to be the answer. I mean, most appropriate answer. Now, somebody might argue so that fluid should be viscous. That part is not given in this answer. That's completely fine. Why? Because they are talking about the properties of the moving body, moving object. It should be relatively smaller and should move through the liquid relatively slowly without setting that liquid in turbulent flow or in turbulent conditions. That's the idea. Okay, fine. So that's about that, and we just not just the answer. I just wanted to revise the stuff, right? The required for you to answer any other question as well. The raised regarding this Stokes law. So Stokes law is a relationship by which we can find out the viscous drag or the viscous force, or we can say simply frictional force produced by a viscous fluid on an object which is moving through that particular liquid or the fluid. Okay, fine, done. Now that's about that, and we are ready to get back to the question number 4. Now in that case, but they have to say just something really simple. Right? They say it is just an object which is being pushed over. Okay, fine. On this particular what's called this platform, right? And that person is going to exert a force of 90 Newton on this one. Okay, fine. Here, 90 Newton, and displacement along the same direction as that of the force is going to be 10 meters. Now, these two figures will tell us to get some idea about 90 Newton and what do you say, 10 meters. Now, these two guys are getting connected with each other when it comes to work done. You know about that thing, right? So direction and the displacement along the same direction as the force. So we can calculate the work done by this person, right? So if it is WD, work done by the person, that's going to be a W is equal to force multiplied by the displacement along the direction of the force. And force applied is going to be 90 Newtons. And the displacement along the direction of the force is going to be 10 meters. So we're going to get 900 joules of work. What is that? The amount of work done by the person. And my brother, now at the beginning, that the block is going to be somewhere there here. And ultimately, it's going to be somewhere there. So effectively, it has gone, it has gone up by how much? With respect to this horizontal bottom, it has gone, to that level. That's going to be 4 meters, right? So effectively, object has been raised by 4 meters against the weight of that object, which is 200 Newtons. Right, fine. So that is going to give us the amount of work done, or just the useful amount of work done, right? So we can say the useful output or energy output, right? We can say just output is equal to here we have 200. Well, multiplied by, be careful, right? That 200 is fine with 4, so that much number of joules. Now that's going to be the useful work. The amount of work done, the amount of work to be done, right? The purpose to be accomplished, and but actually this person is going to input that much amount of work. Now we have discussed about the efficiency. Efficiency eta is given by, so we know useful output divided by total input. In which case we are going to get output is going to be 200 multiplied by 4 divided by, now this input is going to be basically is 90 multiplied by 10, right? So now answers, they have given in the form of expressions, so that I mean, it is not required for you to just what do you say, tapping the numbers into the calculator and to get the answer. Don't be in a hurry or don't be in haste. Just I mean, have a look into your, I mean, into the form that they have given the answers. So here you have the multiplications, divisions, parentheses, right, additions, and so forth. So therefore, they want you to understand how that is going to appear. That's all. So 200 into 4 divided by 90 multiplied by 10 is going to be the answer. So can you find something like that here? The obviously answer can be selected pretty easily and pretty quickly. That's not the answer. And the 200 multiplied by 4, and here it is not that one. And 200 into 4 divided by 90 multiplied by 10. So obviously that's going to be the answer, and we don't want to waste time. Just we can select that answer at once. Okay. Now capital A is not the answer. Why? Because capital A is 90 into 10 over 200 multiplied by 4, which is the reciprocal of the required answer. Right. So that's not the efficiency. It is the 200 multiplied by 4 divided by 90 into 10. Right. That's all about that thing. And now we can get back to question number 5. Question number 5, they say, okay. According to Newton's third law, when two objects interact, okay, let's say with each other, they exert forces on each other. Now, in lessons, we have discussed about this thing, right? Especially when it comes to the Newton's laws of motion. We have talked about the properties, right? Actually, there are 5 important properties, right? So let's say we do have one object here, and we do have another object there. If we just revise in a flash, so the force exerted by one object on the other, let's say one is going to be this way, and then the other one is going to be that way, right? And one important thing is that these two forces, I mean, action-reaction pair, they should always be equal in magnitude, right, and opposite in direction, just as some straight line segment. Okay, they lie on the same straight line, right? So if we just summarize, number 1, they should be equal in magnitude, right? Equal in magnitude. Number 2, opposite in direction. Number 3, they should be collinear, meaning they should lie on the same line segment. And number 4, they should act on 2 different objects, acting on 2 different or 2 distinct objects. And number 5, they should be of the same type. Of the same type, right? So these are the properties. So all 5 properties, all 5 characteristics should be satisfied for 2 forces to be addressed as action-reaction pair. Now, having this the understanding, the forces act at the same time. Now they're asking about not, correct, right? So at the same time, That's correct. Forces act in the same direction. Something has gone wrong with that, right? Because we have said here opposite in direction. And the forces act on different objects. Okay, fine, that's also correct. Now we have this part here, the acting on two different objects here, right? And the forces have the same magnitude. That's also correct, because we have said already the two should have action reaction pair should have equal magnitudes. So therefore, obviously, it's going to be B, because action reaction pair should always be opposite in direction, right? They can never act along the same direction. Something really simple, but you have to learn something as well, right? I mean, action reaction pair should satisfy not only those two famous notorious conditions, equal in magnitude and opposite in direction. Not only those two. There are three additional conditions to be satisfied as well. So all 5 properties are satisfied by these two forces. Then they get qualified to be said to be action reaction pair. That's the idea. Okay, fine. So with that one, we can get back to the question number 6, right? So now the question number 6, question number 6 onwards, from question number 6 up to question number 10 will be taken into account in another video session. Okay, so now just try to learn the stuff, right? And the way we reach the answers, no matter how simple it is, probably you are confident enough to grab the answer all of a sudden just after looking into the question. So that's completely fine. For the time being, just keep practicing how we reach the answer. I mean, what is the logic behind? I mean, what are the things to be calculated? What are the things we should recall into our memories to get that answer? I mean, or just to reach the answer.